Next, this problem, an inorganic salt A is given. It is a colorless crystalline solid. Of course, in the last class itself I have told you, if a salt is colored, that means presence of copper, nickel, manganese, iron salts and so on. If a salt is colorless, it indicates the absence of copper, nickel, etc. So, if color is present, it indicates the presence of copper, nickel, iron, etc. salts. If it is colorless, it means absence of those salts. But if it is a colorless crystalline solid, we cannot come to any conclusion regarding the presence of the salt. But only from reactions we have to come to certain conclusions. All right. B. This salt A is heated. On heating, three products are formed: B, C and D. So, from the color we come to the conclusion that the salt does not contain copper, nickel, iron, manganese and so on. Action of heat. The salt A is heated strongly and it gives three products: B, C and D. And some points, of course, by the action of heat again, it is not possible for us to come to any conclusion. What is the nature of B, C or D? I don't know from reaction B. All right, come to C. One of the products B, it is a residue. Residue means it is a solid. And it is also mentioned this residue B is a metal. So, come to B. When the salt is heated, it gives rise to B, which is a residue. This B is not a compound of that metal, but it is the metal itself. So, here is an indication. B is a metal. All right. What about C? C is, it is oxide of nitrogen. C is oxide of nitrogen. All right. That means the original compound A, since it gives C as one of the products, this original compound A should contain nitrogen in some form. Nitrogen in some form means it may be a nitrite or it may be a nitrate. Of course, we don't know, it may be the ammonium compound. Let us see whether further points will clarify some points. All right. Oxide of nitrogen means even though it is not given, it should be a gas. But this oxide of nitrogen may be NO or NO2 or N2O. So, it is given that C is an oxide of nitrogen, that's all. But what type of oxide it is, we don't know. All right. D. Come to this point. D, a third product, is said to be a gas. Just now I have told you, if it is an oxide of nitrogen, it is also a gas. D is also a gas. But it is given D, which is a gas, is absorbed by alkaline pyrogalol solution. Now, this is a clue regarding the identification of D. A gas which is absorbed by alkaline pyrogalol is oxygen. alkaline pyrogalol solution absorbs oxygen. So, I come to the conclusion that D is oxygen. Of course, regarding A, B, C, I don't know anything. All right. Come to reaction F. Again, A is a salt solution actually. A in the form of aqueous solution is treated with tap water. Immediately, as soon as the first drop of tap water is added, you get a white precipitate, which is E. Of course, here is another clue. If tap water gives immediately a white precipitate, that white precipitate will be usually AgCl, silver chloride. So, E is AgCl. But whether E is AgCl or not, further reaction. This E white precipitate is treated with ammonium hydroxide solution in which it dissolves. This white precipitate E, when treated with ammonium hydroxide solution, dissolves completely to give a clear solution F. Usually AgCl, which is a white curdy precipitate, curdy white precipitate we call it, it dissolves in drops of ammonium hydroxide to give a clear solution. This F is therefore this complex, which is a solution. E is a precipitate, but E dissolves in ammonium hydroxide to form this complex, which is present in the solution. All right. So, these reactions indicate the presence of some silver salt. Come to G. This salt solution is treated with KCN solution. G, a white precipitate is formed. If it is a silver salt, of course, these points indicate that the presence of silver salt. Now, A with the KCN, G white precipitate, this white precipitate is AgCN. But another point is given here. G, the white precipitate, is treated with the excess of KCN, in which this precipitate dissolves to give H, a clear solution. H is a complex. It is, of course, KCN is given. So, K AgCN twice, this complex is formed. So, H, which is a clear solution, contains this silver complex. All right. The last reaction, H, consider the original salt solution, add sodium thiosulfate solution in which you get a white precipitate I. This white precipitate, when you keep it, you allow it to stand for some time, we notice the color changes. The white precipitate changes its color. The change of color is stepwise. White precipitate, yellow, light yellow, dark yellow, brown, and finally a black precipitate J is formed. In the last discussion, I have mentioned one reaction which is known as play of colors. Play of colors, it is a characteristic test for thiosulfate. But here we find this I is Ag2 S2 O3, silver thiosulfate I. On standing, it changes its color to black. J. J is Ag2S, silver sulfide. Now, of course, they have identified some of the compounds D, E, F, G, H, I, J. But what about A, B, C? A colorless, of course, from all these reactions, we come to the conclusion that the original salt A is a silver salt, because all these reactions illustrate this point. And a colorless crystalline solid a colorless crystalline solid which normally we use for reactions is silver nitrate. A is silver nitrate, a crystalline compound. Silver nitrate on heating gives Ag, NO2 and O2, three products. Ag, NO2 and O2, three products are formed. Now you can notice, on heating this salt, we get B residue, a metal. So B is Ag. This is B. Oxide of nitrogen C. Of course, I could have given one clue which I have omitted. Oxide of nitrogen NO2, if I could have given B is a brown, I am sorry, the C is a brown gas, immediately you might have understood it is NO2, and this color purposely I have omitted. What about D? D is oxygen. How do you know that it is oxygen? Of course, AgNO3 on heating gives oxygen, but here is a clue. Gas oxygen, D, it is absorbed by alkaline pyrogalol. So the gas that is absorbed by alkaline pyrogalol is oxygen. So the answers are A, AgNO3, B, Ag, C, NO2, D, O2, oxygen, E, AgCl, a Cardi white precipitate, which is soluble in excess of ammonia, forming this complex F. Similarly, with KCN, the white precipitate G is AgCN, which also dissolves in excess of KCN, forming a clear solution which is H, KAgCN twice complex. Then I, with the sodium thiosulfate, the white precipitate is silver thiosulfate. This silver thiosulfate undergoes play of colors on standing. It slowly changes its color in steps to give finally a black precipitate, namely silver sulfide, which is J. So from A to J, all the compounds, I think we have identified A, B, C, D, E, F, G, H, I, J. So you have to get a clue from the reactions given, from which you can easily identify various products if you know the characteristic reactions of several radicals and the characteristic reactions of several metals. Do you follow?